I'm Kiriti, this is Team 8. Our main focus is the project Efficient Detection of Deceptive Content Using Deep Learning. With big tech giants like Facebook or Twitter, as well as universities and academics investing a lot into fake news detection, we can be sure of its societal impact today. But at the same time, relevant literature shows a lot of promising methods that are still just emerging. Some of these methods are stance detection, content-based detection, temporal-based detection, or propagation-based detection. Our main contribution through this project has been to pair the best deep learning models with the most promising detection methods to show which detection methods are working, which combination of methods are working, and with which models. Our main approach is to combine these detection methods into a classification problem and check which deep learning models are making the best of these detection methods. An important first step in approaching this problem mathematically is to consider and define what is fake news. Now, if we understand fake news as a property of a particular news article, then it becomes that fake news is basically online mentions or social media posts of a certain news story. Now, if we consider news story A and its several posts about news story A online as AS and so on, we can consider the classification problem as labeling the news story A as fake or not by using features of its online media posts. Content-based detection, we are taking language of the social media post as a feature. Temporal-based detection, we are taking the times between the posts as another feature of the data. And user features, this is the features of the users who have posted this data. And propagation, we are taking the propagation tree of these posts as another feature of the data. Taking all these approaches and making them features in the data that we feed our model gives us some of the best accuracies and results that we have seen in this field so far.
Hi, I'm Abrar. I'm from COEP and I'm going to discuss the dataset and its structure.
In our model, in our project, we have used different variety of datasets like liar, Twitter 15, Twitter 16, election day tweets dataset, fake and real news dataset. Each of these datasets have their own unique data and uniqueness of the different columns. All the data sets have labels which are binary classified or are multi-class classified. Uh, the different columns serves a different equal importance. Most of the datasets have news text, news URL, author, subject of the news, which can be used in our detection. Uh, Twitter 15 dataset, like as we can see, different number of examples are there and are multi-class classified as unverified, true, false, and non-rumor. So it also has tree type temporal data which can be used for temporal as well as propagation based detection. So using these different types of data sets, we have acquired a uh, variety of skills by seeing which of the column has most important and then implementing that column in our model. So let's move further.
Hey guys, I'm Rohan Asnani and I'm pursuing my BTech from Tharuman Shani Engineering College. And today I'll be explaining the methods and the models that we have used in our project. So our project is basically broken down into four parts. It starts from text pre-processing, then we tokenize the data, and then the tokenized data is fed into word embedding, which vectorizes the data, and we get a matrix. Then this matrix is fed into the models, and then we get the desired output. So text data requires pre-processing to implement machine learning or deep learning algorithms on them. There are various techniques widely used to convert text data into a form that is ready for modeling. So we first start by removing stop words from the text data available. Stop words are most common words in a language which do not provide much context. What can be these words? These words can be any conjunctions or prepositions like and, to, but, from, etc. So these words need to be filtered out and need to be removed so that it doesn't harm the processing time. And as you can see, when, you, how, they, spent, it, all these are stop words, and these stop words needs to be removed. Hence we use stop word removal. So the second step now is punctuation removal. So in normal language or natural language, punctuation is basically a grammatical context. But here it doesn't mean anything, and stuff like comma, question mark, at the rate, they should be removed as they don't have any context. The third part is stemming. So what stemming is basically it removes the suffixes and the prefixes from a word. And for example, follows, and following can be derived into a single base word, that is follow. What this does is that it increases the space of our vocabulary, and this is very important as it creates room for more stuff or more words to come in, and this really impacts on our accuracy and really improves our accuracy as we can take in more words and increase the size of our vocabulary. So now let's move with glove word embedding. So glove word embedding was recently removed by Stanford. It is basically a tool. So now computers can't speak English, as you know, but glove word embedding it can predict stuff, and it was a throwback or a limitation in word embedding, bag of words basically. So it couldn't predict stuff, but here we can predict stuff such as king minus man plus woman will be equal to queen. So word embedding basically converts a word into respective vectors and creates a co-occurrence matrix. Tokenization is pretty straightforward. So to automate the process of tokenization, we use TensorFlow Keras, and we use the tokenization object. So first we create the tokenization object and we provide it with the maximum number of words that we want to keep it in our vocabulary. So, and we also provided with the unseen word which we haven't seen in our dictionary or the training part yet. So, for example, the cat sat on the mat. This sentence is now split into different words. The cat sat. These are split into different words, and each word is assigned the number. So for suppose the we had removed it in the second step of our data pre-processing, and that word is dropped, and we don't tokenize that basically, and the tokenization part will not exceed the number of words that we have provided to be the vocabulary. So CNN is basically used for image classification. Wait, that's a misconception. So a recent paper said that CNN can also be used for text classification, and it is actually better than RNN. So what CNN is basically consists of neurons that have learnable weights and biases. It has an input and output layer, and it can have multiple hidden layers. And what this hidden layer has, it basically has the convolutional part, the pooling layer, the fully connected layers, and normalization layers. Deep CNN. So deep CNN is an advancement of CNN, and it consists of many neural network layers. The two different layers is max pooling layer and the convolution layer, and mostly these layers are in an alternative arrangement. As you can see here, convolution, max pooling, then again convolution, then max pooling. The depth of each filter increases from left to right, and the last layer is mostly the fully connected layer or the dense layer. More the layers, better the accuracy, but sometimes this leads to overfitting. So take care. Traditional neural networks can't remember stuff. They can't predict stuff based on their past execution. This problem is overcome by LSTM. LSTM addresses this issue. They are networks with loops in them, allowing information to persist. Now, a LSTM unit is composed of a cell, an input-output gate, and a foreign gate. The cell is responsible for remembering values over a vast time interval, so that the relationship of a word in the starting of a text can influence the output of the word later in the sentence.
Here are the results for the classification that we did with each model. So, these are the observed results of the models which we have experimented along with the proposed model. Therefore, here are the different datasets which we have used. We have used four types of datasets. First dataset which we have used is fake and real news. The models which are used in this are CNN, Deep CNN, and LSTM. The accuracy which is observed in CNN model is 96%, in Deep CNN it is 91%, and in LSTM it's about 84%. The fourth dataset is Twitter 16. In this CNN model, the accuracy observed is 79%, and Deep CNN shows the accuracy of 93%. So, these were the three who has been the main model accuracies are observed.
Hello everyone, I am Piyush Sabre and I am pursuing my BTech in Computer Science Engineering from G.H. Raisoni Institute of Engineering and Technology, Pune.
After analyzing the results produced by the different models which we have implemented, namely CNN, Deep CNN, and LSTM, we came to a conclusion that models produce good test and train accuracy on all 5 datasets. It gives us an effective approach to classify fake and legitimate news. Even if the limited data is available for training, it works with the same effectiveness and on the different dataset with consistency. By adding the temporal based detection to content based, more consistent and slightly better accurate results are being produced. Throughout this project, the matching of deep learning models and methods to datasets available, especially important datasets like Twitter 15 and Twitter 16, has been produced desirable results by increasing accuracy and employing new propagation based approach where the time differences between the posts and the repost are trained along with the content and the corresponding labels. Thank you.